Welcome to Real Civil YouTube channel. In this video, we are going to see how to formulate a mass matrix and a stiffness matrix, which will be the part 1. And in upcoming parts, we are going to see how to find out the natural frequencies as well as the mode shapes. So this is what we are going to do in this series of MDOF multi-degree of freedom system analysis. Okay. So our first part is related to the formulation of mass matrix and stiffness matrix. This will be our part 1. In second part, we will see natural frequency, and in third, we will basically see the interpretation of the modes. Okay, so let's begin with the example. I have a two-story structure. Draw the figure here. So these are the two stories. So the stiffness given for the bottom story is 2K and K for the top story, whereas the mass of the first floor or the floor is 2M and the top story mass is M. Okay, and the building is displaced in the right direction having the displacement U1 and U2. Okay, the another detail given as is mass is 180 into 10 raised to 3 kg, and the stiffness given is 11 into 10 raised to 7 Newton per meter. Okay, so we will use this data in our part 2. It doesn't have any requirement for this particular video. Okay, so let's begin. Uh, So first step is we have to formulate the mass matrix and stiffness matrix. For that, we'll have to use, we have to first draw the free body diagram. So always remember, we will start from the top story for the free body diagram. So this is the mass. Okay. So I have drawn a cut section here. Now, what are the forces are acting on this structure? So this is the displacement U2. Okay. Now, first thing is uh, we will consider uh, this mass right now for simplicity as M1, and this mass we will call this as a M2, where this stiffness 2K we call this as a K1, and this stiffness K we called it as a K2. Okay, just for simplicity we will then put all these values. Okay, so as the it is moving to the right side having displacement U2, we will have inertia force as per the D'Alembert principle, which says mass times acceleration. Okay, so mass of this floor is M2 and the acceleration is U2 double dot. Okay, now as you can see here, see the structure is something like this. Okay, and it is deflected like this. Okay, and this is U2 basically, and this is U1. Now you have to remember that the acceleration must be absolute, whereas the displacement and velocity are always relative. Okay. Now, as our structure is moving to the right side here, U2, so the stiffness will try to bring back the structure. That's why I will show the direction left side. Okay, stiffness of this floor we have written as a K2. Okay, and as I told you, we have to take relative displacement. Means what? Here the displacement is u2 and here displacement is u1. So we have to consider u2 minus u1. Okay, now this is the free body diagram for the top story. Uh, Now I will draw the free body diagram for the first story. Okay, this will be the cut section. As you know, here it is 2m. Okay, the displacement here is u1. One is the displacement. Okay, now as per the D'Alembert principle, uh, mass times acceleration. So I can write m1. As you know, this mass we have denoted as m1 and u1 double dot for acceleration. Okay, now as they are connected, here you can see this is the action. Okay, now this will become the reaction for the first floor. So you can show the arrow in opposite direction and write K2 into U2 minus U1. Okay, so that's why I told you that you should go drawing the free body diagram from top to bottom and in a sequence so that you can immediately show the action as well as the reaction. Okay, now as our floor is displacing in the right direction with U1 displacement, the stiffness provided by this floor, which is K1. Now we have to consider the displacements. Okay, here it is u1 and here it is 0. So I can write u1 minus 0, which will try to bring the structure backward. Okay, so this is the free body diagram. Now our job is to write the equation. Okay, so how to write equation? So I will write the equation for the top story here. So first we'll consider left side positive, right side negative. So m2 u2 double dot. Next, again this force is there, plus k2 into u2 minus u1, and then there is nothing, so equal to 0. And for the first story free body diagram, okay, so m1 u1 double dot, left side left, it is going to the left, so we'll consider positive m1 u1 double dot. Then again I will consider this force, stiffness force, plus k1 u1. I can write k1 u1 as it is, the second part is 0. Now this part is going towards right, so I can write minus k2 into u2 minus u1 equal to 0. Okay, so now you have to given the numbering to the equation. So always remember drawing the free body diagram from top to bottom, but write the equation from bottom to top. So equation 1 and equation 2. Okay. For more simplification, I will rewrite the equation 1 once again, but with a little change. Okay. So as you can see here, m1 u1 double dot. Now there is no any u2 double dot term is there. So I will just write plus 0 u2 double dot. Okay, as it is no u2 term is there, so I can write 0. Okay, plus k1 u1. Now I will write k1 u1 like this is K1 U1, and if I multiply here, I can write minus minus plus. So plus, just a minute, I will rewrite once again. So as you can see, M1 U1 double dot plus K1 U1 minus K2 U2 plus K2 U1, okay, equal to 0. Now I will write in this form. So M1 U1 double dot. As I told you, there is no any U2 double dot term, so I can write plus 0 U2 double dot. Okay. Next, I will write U1 term. So my sequence will be like U1 double dot, U2 double dot, U1, U2. Okay, now U1 double dot I have written, U2 double dot is 0. Now I will write U1 term. So here you can see this is the U1 term, and here it is U1 term. So I can write plus K1 plus K1 plus K2 U1. And now here it is K2 term is there, so minus K2 U2 equal to 0. So this is my first equation. I have slightly modified this equation. Okay, now split this equation. Okay, I will rewrite once again. Here the equation was something like that, M2 U2 double dot, okay, plus K2 into U2 minus U1 equal to 0. So this was the equation. So I can write M2 U2 double dot multiply. So first write K1 U1, okay, or U1 term, which is basically minus K2 U1. Now write K2 term, which is plus K2 U2 equal to 0. Now again we will rewrite this equation. As you can see, there is no U1 double dot term is there. So I can write 0 U1 double dot, next plus this M2 U2 double dot. Okay, so we have written U1 double dot, U2 double dot. Now we have to see is there any U1 term is there. So this is the U1 term. So minus K2 U1 and then plus K2 U2 equal to 0. So this is my equation number 2. Okay. Now I have to formulate the stiffness matrix or mass matrix. Okay. So this will be my mass matrix. Then this is U1 double dot and U2 double dot. Then this is my stiffness matrix, which is U1 U2 is equal to 0. As I have not considered the damping and external force, so this much is enough. Okay, now focus on this equation. Okay, so M1 U1 double dot. So I can write here M1. Okay, then 0 U2 double dot. So I will write 0. Now in the second equation, U1 double dot term is 0. So 0. U2 double dot term is M2. So M2. Next, here U1 term is K1 plus K2. So in bracket K1 plus K2. U2 term is minus K2. Minus K2. Here in second equation U1 term is minus K2. U2 term is K2. So this is my mass matrix for the given problem, and this is my stiffness matrix for the given problem. So this is how you can formulate the mass and stiffness matrix. As it is for 2 degree of freedom, U1 and U2, you can do it same way for 3 degree of freedom system also, 4 degree of freedom system also. Okay, only thing is that you have to consider it as a lumped mass system, and you have to draw the free body diagram, and you have to write the equation. So this mass matrix is a diagonal matrix, okay, and this stiffness matrix is a symmetric matrix, okay. So here you can see our m1 is 2m and m2 is m. So I can write now the same equation as, we know that m1 is 2m and m2 is m. So 0, 0. So this is my mass matrix. And for stiffness matrix, we know that here you can see the K1 is 2K and K2 is K. So K1 plus K2, that means 2K plus K, this will become 3K. K2 is K, that means minus K and K. So this is my stiffness matrix. Okay, so mass matrix and stiffness matrix for this particular problem. Now you can put the values also. Okay, you can see here it is 180 into 10 raised to 3 kg and 11 into 10 raised to 7 Newton per meter. So that is enough for this lecture. We will see the detailed problem in our next lecture, where we will calculate the natural frequency, and I will show you the simplest way how to calculate the natural frequency and mode shift. Okay, so thanks for watching. Please like, share, subscribe the Real Civil YouTube channel. Thank you.